Section 4.4 problems. Problem 1, solve that exponential equation there. Okay, we did this on the PowerPoint slide. Now, I guess I'll just mention that since 5 to the third power equals 125, therefore it follows that the exponent, which is 3x minus 6, must be 3. Because if this were a 3, then 5 to the third is 125. So that's a different way to think it through. Notice we didn't use the property b to the m equal b to the n. We thought through in a different way. But that only works on very simple ones. Okay, let's see what else we got. Problem 2. Problem 2. This one we did on the PowerPoint slide. So let's do a new problem 2 here. New problem number 2. Okay. How about something a little different? 3 to the 1 minus x power equals 1 divided by 27. Okay. Is this a problem that needs logarithms, or is this a problem that we can make like bases on either side? Well, we know that 3 to the third power is 27. So I can rewrite this to be 3 to the 1 minus x is equal to 1 divided by 3 to the third power, since 3 to the third power is 27. From there, I will use a rule of exponents. And I'll bring this up from the bottom, and by doing that, the power turns negative, using that rule of exponents. Now we have exactly b to the m equal b to the n. So we can use that property and get 1 minus x must be negative 3. So let's see if we can bring the x over there. So we get 1 plus 3. So bringing 3 to the left, adding 3 to both sides, adding x to both sides. So then you see x is equal to 4. Okay, that's 4. 1 minus 4 is negative 3. Yes, 3 to the negative 3 means 1 over 3 to the third power, which we know is, I see, 1 over 27. Okay, so there's our new problem number 2. Let's see what else we got here. Problem number 3. Problem number 3. Solve 10 to the x equals 8,000. 8,000. Well, if it were 10,000, that would be fairly easy, since 10,000 is representable as a power of 10. But 8,000 is not. So this one is going to involve logarithms. Now, again, it doesn't matter, natural log or common log or any base that you wish, but it might make more sense to use the common log since we have the exponent, the base of 10. And common log of one side, then you're forced to take the common log of the other side. Okay, now we can use the power property. X times log of 10 is equal to the log of 8,000. Okay, and the common log of 10 is 1, so this is just x. X is the log of 8,000. Okay, so you can approximate that on a calculator if you wish, but that is the exact answer. Now, if we didn't use common log, but instead natural log, how would that look? So let's push this up here and try. The natural log of 10 to the x equals the natural log of 8,000. So x times the natural log of 10 is equal to the natural log of 8,000. See, this is not 1, so you have one more step. You have to do some division here. So we have the natural log of 8,000 divided by the natural log of 10. And that is the same answer. In fact, think about the change base formula. Log base 10 of 8,000 is log base e of 8,000 over log base e of 10. That's just the change of base formula from here right to here. So that is change of base. In other words, you don't need to solve the equation again. You can go from here directly to here using change of base, or you can view it as a new problem where you take the natural log of both sides and still get the exactly the same result as using the common log. Okay, let's see what else we got here. Problem number 4. 7e to the power 2x minus 5 equals 58. 7e to the power 2x, subtract 5 equals 58. Okay, that is an exponential equation because our variable is in the position of the exponent. So let's do something easy. Let's add 5 to both sides. 7e to the 2x, and that'll be 63. And then divide both sides by 7, so e to the 2x, 63 over 7, turns out to be 9. Okay, so then e to the 2x is equal to 9. Okay, so having come that far, we've isolated the exponential. That is the key. Now take the logarithm. I would choose the natural log since we have a base e here. So we'll take the natural log of both sides. Okay, and then we'll use the power property. So 2x times the log of e is equal to the natural log of 9. Okay, and then let's come up here a little bit. Natural log of e is 1, so that's 2x is equal to the natural log of 9, and therefore x is equal to the natural log of 9, all divided by 2. And there is our solution there. Take a look at the next one. Problem 5. 4 natural log of 3x equals 8. Okay. That's a logarithmic equation since it contains a logarithm. And you would like to convert to exponential form, but not just yet. You have to get rid of the multiplier here. So I'm going to take what I have, 4 natural log of 3x equals 8, and I'm going to divide both sides by 4. Just get rid of the 4 that way. Well, why not bring the 4 up here? Well, you can, but now you have a quantity to an exponent, and that will create more complex math. But it certainly will work out. Hey, why not try that? You'll end up with the same thing, but it will be many steps more. So this is the path of least resistance. 4's divide out, giving you the log of 3x is equal to 2. Now convert to exponential form. So we'll come up here, and we'll convert to exponential form. The base, e to the power 2 equals the number 3x. Aha! So divide by 3. So e squared divided by 3 is the value, the exact value of x that makes the original equation true. All right. Let's take a look at problem number 6. Problem 6. Okay, this problem we did in the PowerPoint slide, so let's do a new number 6. New number 6, let's say log base 2 of x plus log base 2 of x minus 7 equals 3. Okay, solve that equation for x. Okay, well, now you have 2 logarithms there, so we have to compress this to 1. Make sure you have a 1 in front of each logarithm, which we do. So use the product rule and condense. So this is the logarithm base 2 of x times x minus 7 equals 3. Okay, now we have a single logarithm. So So you can now convert to exponential form. 2 to the power 3 equals x times x minus 7. And then, let's see, so that will be 8 equal x squared minus 7x. Let's get everything on the same side because we recognize that to be a quadratic, so let's do that. X squared minus 7x minus 8, bringing everything to the same side. And we could use the quadratic formula, or perhaps this factors. Let's see if this factors. See, x times x would be x squared. Factors of 8, 8 and 1. So if we use a negative 8 and a plus 1, that would produce the middle term there, negative 7. So setting each piece to 0 gives us two proposed solutions, x equals negative 1 and x equals 8. Okay, always check your answer. Notice if you try to check this one right here, x is negative 1, there's no problem with x being negative. Negative solutions are perfectly fine. But when you attempt to put it all the way back here, you get log of negative 1. That's not defined. So right away, this is thrown out. No good. Now, if you put negative 1 in here, you get another negative number. But just one of these having a domain issue is enough to throw it out. Therefore, the solution set here is only 8, and that's it. Number 7. This is a new one. Medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. The risk is modeled by R is equal to 6 times e to the 12.77x, where x is the blood alcohol concentration and R, given as a percent, is the risk of having a car accident. It's really important you know what the variable and the function measure. Otherwise, things just go wrong. What blood alcohol concentration corresponds to a 7% risk of a car accident? See, this is why you read it, because is this 7% or is it 0.07? And it says R given as a percent. So as a percent then, 7 is its percent. So 7 is our R, and then we need to find the value of x, which is the blood alcohol concentration. Okay, that's what they're asking us to find. What blood alcohol concentration? That's find x. Okay, notice your exponential equation right here. Your exponential is not isolated. So you have to first divide both sides by that exponent. E to the 12.77x. Okay, so let's come back up here. So now we need natural log of both sides. So we'll take the natural log of 7 divided by 6 and the natural log of e to the 12.77x. Okay, so we got natural log of 7 divided by 6. This is 12.77x times natural log e by the power property. The natural log e is 1, so it can be thrown out. Well, not thrown out, it's 1, and 1 times this is just 12.77x. So the natural log of 7 over 6 is equal to 12.77x. In other words, we can just divide both sides by, bring it over here, we can just divide both sides by 12.77. So we got the natural log of 7/6 divided by 12.77 is our x, our blood alcohol concentration. And if we work this out on the calculator, we'll find that x is approximately 0.012. So about a 0.01 blood alcohol concentration. Okay. problem 8. Problem 8. This is what we already did in the PowerPoint slides. So let's see. How can we make this slightly different? Okay, so let's say that how long, let's start that again right over here. How long, let's see, will it take to, let's say, double. Let's double an investment. How long will it take to double an initial investment, let's say $10,000 investment, if let's say we get 8%, and let's compound quarterly, 8% compounded quarterly. Okay, so we made this slightly abbreviated. How much time will it take to double an initial investment of $10,000 if your annual interest rate is 8% and the money will earn compound interest on a quarterly basis? Okay, so let's get the compound interest formula here. A, the amount, is equal to P times 1 plus R over M to the power M times T. Okay, let's put in the values. Now the initial is $10,000. That's P. But if you want to double your money, then the amount that you're going to get out is $20,000. So there's the future value, and here is the, we call that the present value, the initial investment, times 1 plus 0.08, R is always as decimal, compounded quarterly, so that's divided by 4, raised to the 4 times T. Okay. So 1.08 divided by 4 plus 1, that's fairly easy to do. So this is 20,000 equal to 10,000 times 1.02, and the power is 4t. Okay. Now we have to isolate the exponential. That's important that we do that. Very important. Don't have to, but it does make the math more challenging. Divide both sides by 10,000. So 2 is equal to 1.02 to the power 4t. That makes it look a lot simpler. And now we can use logarithms here to simplify and solve for t. So natural log of 2 is equal to the natural log of 1.02 to the power 4t. Use your power property on the right side. Natural log of 2 is equal to 4t times natural log of 1.02. Okay? And so we have a 4 multiplier, and we have this number as a multiplier. That's okay. We can get rid of all of that by division. So we'll divide both sides by 4, natural log of 1.02, and that'll be t. And you can work that out on the calculator. And that's going to give us t is approximately, let's see, 8.75, or if you wish, about 8.8 years. So it's going to take just under 9 years for an initial investment of $10,000 to double to $20,000 if you have quarterly compounding and you get an annual interest rate of 8%. Then that will happen. And that concludes the problems for section 4.4.